2022 was a very fruitful year for astronomy. We explored the depths of the universe like we have never done before and uncovered secrets that have been hidden for many centuries. Scientists credit the James Webb Telescope for most of these accomplishments, and as a matter of fact, they believe putting this incredible spyglass into active service was our biggest achievement of the entire year. But why is the JWST seen as a big deal? Is it really worth the hype? Well, let's find out together. Launched aboard an Orion 5 rocket on December 25, 2021, the James Webb Telescope is the most sophisticated and powerful telescope ever built by NASA. But if it was launched in 2021, why then is it regarded as the biggest astronomical achievement in 2022? Well, the reality is that heavyweight space exploration gadgets take a long time to develop. At the very least, they require decades of relentless work to get them across the finish line, and the James Webb Telescope isn't any different. The telescope had been in development for around 3 decades, and by the time it was launched in 2021, the total cost of the project was estimated to be around $10 billion. Following its successful launch, scientists still needed a couple of months to calibrate and test it, and that's why it didn't officially enter active service until 2022. But as soon as it settled down in its new home, it wasted no time in sending ample feedback to astronomers and scientists on Earth. Upon its launch, NASA confirmed that the exceptional spyglass was specifically designed to focus on 4 scientific areas, including the first appearance of light in our universe, the assembly of galaxies in the early universe, the birth of stars and protoplanetary systems, and the origins of life on our home planet. To achieve this, the telescope was equipped with 4 science instruments, allowing it to observe objects in visible, near-infrared and mid-infrared wavelengths at a range between 0.6 and 28.5 micrometers. These instruments include the Near-Infrared Camera (NIRCam), Near-Infrared Spectrograph (NIRSpec), Mid-Infrared Instrument (MIRI), as well as the Fine Guidance Sensor Near-Infrared Imager and the Slitless Spectrograph (FGS NIRIS). Overall, the James Webb Telescope weighs around 6,200 kilograms. Its gold-plated primary mirror, which is made up of 18 hexagon individual mirrors, has a diameter of 6.5 meters. It operates at an average temperature of minus 370 degrees Fahrenheit. But the maximum temperature of the telescope's heat shield ranges from between 231 degrees Fahrenheit to minus 394 degrees Fahrenheit. Critically, the James Webb Telescope came with quite a number of new innovations. For instance, its complex segmented mirror can be folded when required. As a matter of fact, it was folded during the telescope's journey into space. Additionally, its sun shields are also deployable and lightweight. Other impressive innovations incorporated into JWST include micro shutters, the MIRI cryo cooler, cryogenic actuators, the mirror control, and improved detectors. More importantly, this impressive telescope has longer wavelengths than its predecessors. This enables it to look way back to the beginning of time and explore the formation of the first galaxies which had not been observed before now. Similarly, this longer wavelength will allow the JWST to explore the innermost parts of dust clouds where stars and planetary systems are formed. So far, the discoveries made by the James Webb Telescope have been impressive to say the least. But of course, there was always going to be something extra about its very first discovery. Officially unveiled on the 11th of July 2022 in an iconic event at the White House, the first discovery of the JWST featured 4 mind-blowing astrophysical phenomena. They include the glowing cosmic cliffs in the Carina Nebula, the Southern Ring Nebula, Stephan's Quintet, and the detailed analysis of the atmospheric composition of WASP 96b, a hot gas giant exoplanet in the depth of space. Perhaps more significantly, the event was headlined by United States President Joe Biden, Vice President Kamala Harris, and NASA Administrator Bill Nelson. And together, they introduced us to a series of groundbreaking images and discoveries captured by the billion-dollar JWST telescope. Thanks to this amazing work of science and astronomy, NASA was able to capture a stunning image of the deepest infrared view of our universe to date. An official statement released by the space agency confirmed that it took the JWST 12.5 hours to capture this stunning image. In comparison, the Hubble Space Telescope would have needed around 2 weeks to capture the same image. And of course, the quality wouldn't even be on the same level as the image just captured by the JWST. Scientists had known this was the case even before the telescope set out on its journey of no return into space. And the JWST proved them right, even before its first official discovery was made. During the testing and calibration process, the JWST captured its first images of starlight when it zoomed in on a star called HD 84406. The image was captured specifically by the 18 mirror segments attached to the telescope's primary mirror. In the image, the HD 84406 was depicted as a mosaic of 18 scattered bright dots because the individual segments of the telescope's primary mirror was yet to be aligned at the time. However, NASA scientists expected that once it is fixed, these stunning dots would ultimately merge and become visible as a single star. While the alignment process was still ongoing, scientists turned the camera inside the NERCam instrument and captured an amazing selfie of the JWST. This was an iconic moment that piqued the interest of every space enthusiast. But admittedly, it was nothing compared to the excitement that was felt as we expect the first official photos from this first-of-its-kind space gadget. Eventually, NASA officially announced that the alignment phase had come to an end after confirming that all 4 of the telescope's scientific instruments were functioning as they should. And of course, they've played a huge role in all of the discoveries that the telescope has made so far. This exquisite scene on your screen is a high-resolution image of a cosmic cliff at the edge of a massive gaseous cavity within another dusty star-forming nebula called Carina, some 7,600 light-years in space. The finely carved cavity is believed to have been sculpted by the intense ultraviolet radiation and winds from young hot stars. The gigantic mosaic measures 15 light-years from one edge to the other. To put that in perspective, 1 light-year is equivalent to about 9.46 trillion kilometres. Critically, the Carina Nebula isn't just colossal. It is also one of the brightest nebulae in space. S-MAX 0723 is another fascinating astrophysical element that has been explored by the James Webb Telescope. In the image released by NASA back in July, this iconic galaxy cluster was depicted just as it appeared in the early days, some 4.6 billion years ago. The mosaic itself spans across a segment of sky that is equivalent to the size of a grain of sand held at arm's length by someone on the ground. More importantly, it uncovered thousands of galaxies in a tiny corner of the vast universe. Generally, galaxy clusters are the largest objects in the universe that are held together by their gravity. However, NASA believes S-MAX 0723 has such a tremendous gravitational pull that it can warp both space-time and the pathway that light subsequently travels through it. Due to this, bright white galaxies are said to be earning and stretching the light from the most distant galaxies. This makes them somewhat elongated, more like banana-shaped objects. Next, we've got Stephan's Quintet, a collection of 5 galaxies situated in the constellation Pegasus. This phenomenon was first discovered by French astronomer Edouard Stephan in 1877, when the technology behind our astrology machines was still in its infancy. Expectedly, the new image released by NASA shows the Stephan's Quintet in a different way from how Edouard Stephan saw it back in the late 1870s. The gigantic mosaic consists of almost 1,000 individual image files and covers an area that is about 1/5 of the Moon's diameter. From close observation, scientists discovered that 4 of the 5 galaxies in the quintet are locked in a cosmic dance of repeated close encounters. Additionally, the James Webb Telescope gave us a privileged view of the nebula located around 1,350 light-years from Earth. The JWST's imaging of Orion is an exceptional discovery because it is one of the most famous star-forming regions or nebula of the sky. Also, the James Webb Telescope has made countless more discoveries, including quality images of the Cartwheel Galaxy, the Wolf-Rayet star, the M74 Galaxy, and even Neptune, our gas giant neighbour in outer space. With all of these discoveries, it's clear that the James Webb Telescope has launched us into a new era where astronomers can explore the depths of space with little or no destruction. And that's exactly why it's a big deal.